So again, good morning. This week in Algebra 3, today we'll do some graphing. Tomorrow's our off day. Wednesday we'll deal with holes. We'll deal with holes in our graph. That'll be steps 5 and 0. So there's actually 2 steps on Wednesday. Thursday we'll deal with some graphing or more graphing. And then Friday we will take a summative quiz. You need grade group, you know what I mean? But you have your supplemental note sheet, your toolkit, if you will. Okay? So should be 100%. Should be the easiest grade of the year. So on this warm up, just straight up graphing it and then stating the end and horizontal end and asymptotal behaviors. All right. So step 1. Find the domain. How do I find the domain? Set the denominator equals 0. So this would be 2x minus 3 equals 0. So that would be 2x equals 3. So that would be x equals 3 halves. Yes? Okay. So what is my domain then? All real numbers. Okay. Except x cannot be 3 halves. Second part of step 1. What's the vertical asymptote then? X equals 3 halves. Okay. How does that go on our graph? But how? It's a line, right? Dashed line. Okay. Straight up and down, straight horizontal, skewed, up and down. Okay. And where is it? At roughly 1.5. So that would be somewhere right in about there. Agree? Okay. Step number 2. What is the ha? Degree at the top? Degree at the bottom? 1. So they're the same. So that means a over b, y equals a over b. A on top, 5. B on the bottom, 2. So it's y equals 5 halves. How does that line go on our graph? Dashed and horizontally. 2.5 up from the x-axis. Okay. Step number 3. Find my y-intercept. How do I find my y-intercept? Plug in 0. So that's going to be 0 divided by -3, which is going to be 0. So the origin is my y-intercept. Step number 4. X-intercept. How do I find my x-intercept? So that's also going to be the origin. Okay. Step number 7. More points, right? Got to have more points, at least 2 on either side. So let's go with positive 1. If I put 1 in, I get 5 on the top. If I put 1 in, I get 2 minus 3 is negative 1 on the bottom, so that's negative 5. 1, 2, 3, 4, 5. So that's right there. Okay. 4 is a nice one. On top, we've got 20. On the bottom, we've got 2 times 4 is 8, minus 3 is 5. 20 divided by 5 is 4. Oops, we went the wrong way. That's all right. I wanted to go negative 4. Come over here, get that one. 4 is 20 over 5. I forgot the negative sign. Screwed myself up. What do I want here now? Well, let's just go negative 4. Negative 4 would be negative 20 over negative 11. What's that? Almost 2? Not quite? 1, 2, 3, 4, almost 2, so somewhere right there. Okay. I would say that the left side would come through like this. You agree? Right side, we said we know we went through 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Probably do 3. No, excuse me, 2. 2 would be 10 over 1. And then let's just do 10. 50 over 20 minus 3 is 17. So that's almost 3. Because 51 is 17 times 3 is 51. So almost 2.99. So this side looks like that. Then the last part said, or the second part of this one said, find the asymptote and end behaviors. So which one do you want to do first, end or asymptote? Asymptote first, and so my asymptote behaviors would be as x approaches 3/2 from the right. What's my function doing? So the right side of the blue line, what's my function doing? Going to positive infinity. As x approaches 3/2 from the left side of the blue line, what's my function doing? Negative infinity. Those are my 2 asymptote behaviors. Let's go. Then we got end behaviors. As x is going to positive infinity, what's my function going to? And as x is approaching negative infinity, what's my function going to? So top one is right side of my graph. As I get farther and farther over to the right towards the door, what's my function getting closer and closer and closer to? To what? No. To 5/2, right? Closer and closer to the horizontal asymptote. From above or from below? From above. So that would be 5/2 from above. As the function gets closer and closer and closer to me, because I'm on the left side of the graph now. What's it getting closer and closer and closer to? 5/2 from below. Bottom side of 5/2. Questions on that one? Good? All right. Go for it. Don't give me that look. Look, read the directions. What does it say? Graph it.
I am graphing.
I know it doesn't. No, this one's giving me a look. This heckin' York girl's giving me a look. She's mad at me because she thinks I'm gonna make her do end behavior and asymptote behavior. Does it say do that? No, so you just gotta graph this one. Thanks, Linz. Step 1. Domain. How do I find the domain? Set the denominator equal to 0. Okay? So even the more complicated denominators, we still set them equal to 0 to find our restrictions in our domain. Factorable, not factorable. Factors into x minus 2 and x plus 1. So then x minus 2 would equal 0. So x would be 2. X plus 1 would equal 0. So x would be negative 1. So the domain all real numbers. If you wrote them both as x cannot equal 2, x cannot equal negative 1, this time you can write it like that. Okay? Vertical asymptotes then. Two and negative 1. Good on that. Okay. Horizontal asymptote would be step number 2. Y equals 0. Degree on top is 1. Degree on the bottom is 2. Small over big is y equals 0. Y-intercept is next. Plug in 0. So we get 0 on top. 0 minus 0 minus 2 is 0 over negative 2, which is just 0. So it goes through the origin. Ruh-roh. What's wrong with that? Is there anything wrong with that? Nothing? What's wrong? What do you mean? Or why, I should say. Is there anything wrong with it? Visually, what looks out of what's the one thing that's different in this one? That's okay. Doesn't always have to be centered. It's on the horizontal asymptote. Is that mathematically legal? Yes or no? But didn't it all work out? Like, if it wasn't legal, wouldn't we gotten like a divided by 0 or something like that? Math is all a sham. Dogs and cats do live together. Mind-blowing fact number 87 this year. Your function can cross a horizontal axis. It can't cross a vertical axis, but it can cross a horizontal axis. Just so you know, I won't write this down. Functions can cross a horizontal axis. So this is mathematically sound. Okay? It won't cross it at the extremes, at positive or negative infinity. It won't cross there. It'll cross somewhere in the middle, somewhere that you can see it. Okay? Fourth step then is our x-intercept. Our x-intercept set the numerator equal to 0, so x just equals 0, so that is also 0, 0. Okay? So then we've got 3 zones now that we've got to come up with points in. Okay? So we'll work left to right. So I would say I would try here -2 and -10 into my function. If I plug in -2 into h of x, I would get -2 on the top. -2 squared is 4. 4 minus -2 is 6. 6 minus 2 is 4. So we get -1/2 there. -10 would be -10 on top. 100 plus 10 is 110. Minus 2 is 108. That's going to be like -0.1. So this zone of the graph is right there. In the middle section, I would try 1 for sure. 1 over 1 minus 1 minus 2 is -2. So we're there. Since a couple of math things that you probably picked up along the line, somewhere along the line, since we only have this one intercept, okay, this function can't come down from here and then turn and go back up, because we only have one x-intercept. Okay? And since this numerator, this x-intercept was a singleton, it's not a bouncer, meaning that it wasn't x squared equals 0. It's got to come down from here, cross over, and make the turn. Double roots, remember, are bouncers. This wasn't a double root, it was a single root, because it was just x in the numerals. Then we've got the right half, or the right zone, so that would be 1, 2, 3. If I put 3 in there, I got 3 on the top. 9 minus 3 minus 2 is 4. and then 10. 10 would be 10 on top, 88 on the bottom. That one looks like... If we would have had to have done asymptote and end behavior, we would have had 2 end behaviors and 4 asymptote behaviors. We would have had left and right side of -1, left and right side of +2. Okay? One last one for you to do. So step 1 says we need to set the denominator equal to 0 and find the domain. Right? So what's my domain? What? Just straight up all real numbers? No restrictions? Because the restrictions are imaginary. So they're not real. So what does that mean for vertical asymptotes? There are none. Done. Horizontal asymptotes. Y equals 2. Degree on the top is 2. Degree on the bottom is 2. So that's same over same. Lost my train of thought there for a second. Same over same. So that means that y equals 2 is my horizontal asymptote. Like it? Okay. Y-intercept. Plug in 0, right? If I plug in 0 on the top, I get -10 because the x term goes away. If I plug in 0 on the bottom, I get +5 because the x term goes away. -10 divided by +5 is -2. X-intercepts. Set the numerator equal to 0. Solve it. So I have 1 at the square root of 5, 0, and I have 1 at negative square root of 5, 0. Square root of 5 is what? A little bit more than 2? Okay. So then we should probably try +10. If I put +10 into my function, 10 squared is 100, times 2 is 200, minus 10 is 190. 10 squared is 100, plus 5 is 105. Approximately 1.9-ish. Yes? If I plug in -10, I get the exact same thing. So my function is going to come through here. little dip-a-roo. Do I have any asymptote behavior to discuss? No, because I don't have vertical asymptote, so I have no vertical asymptote behavior. So that just leaves me with end behavior. And my end behavior would be as x approaches positive infinity, f of x is going to approach 2 from below. And as x is approaching negative infinity, f of x is going to approach 2 from below. And that's that. Questions, comments, concerns, clarifications? Oh, yep. Mm-hmm. So on the blue worksheet this week, you can do the front side, which is numbers 1 and 2. We will be having a summative quiz on Friday of this week. And again, it is progress time, so I handed out progress reports for you. If there's anything on there that you think is fixable, you need to get any fixes into me before tomorrow. Before the end of the day tomorrow, and I'll make sure that it gets on there because my progress grades are due Wednesday. So, again, anything on that progress report that can be fixed would be anything that is formative, okay, or homework. Homeworks and formatives can be fixed. Tests and quizzes